Today we're going to talk about anti-money laundering and how Neo4j can be used to improve anti-money laundering investigations. We'll start by just taking a quick overview of what is money laundering, and we'll talk a little bit about the regulatory landscape for anti-money laundering around the globe. We'll address some of the typical problems that arise during anti-money laundering investigations and kind of pitfalls in the processes. And then we'll talk about how Neo4j can help with those. And then we'll see a live demonstration, an example of an anti-money laundering investigation using Neo4j and our Bloom visualization tool. And as Angelica said, at the end, we'll have a Q&A, so please do ask questions. So what is money laundering? It isn't about washing money, although quite amusingly, there was a recent news article about some money laundering suspects that actually had money stored in a washing machine, which is kind of funny. But seriously, money laundering is a big issue, right? It can be used to fund terrorism. Usually money that's laundered comes from criminal activity. So it's a really big issue. Society really tries to stop money laundering, and banks and financial services institutions tend to be at the front line of that effort. The exact definition of money laundering from Wikipedia we have here is the concealing of, it's the act of concealing the transformation of profits from illegal activities and corruption into ostensibly legitimate assets. So if you are a criminal and you are making money and you don't want people to know that you're a criminal and that your money comes from criminal activity, you need to launder the money, right? So you have dirty money, you want to clean it so that you can then use it in the normal economy. Who needs to launder money? Anybody really who is making money out of illegal activity, right? These could be embezzlers, they could be drug dealers, they could be criminal gangs, the mafia, individuals who have sanctions against them for whatever reason, smugglers, human traffickers, right? It tends to be a very cash-oriented type of scenario, but anything really, any criminal activity that generates profit, those profits will need to be laundered so that you don't raise the suspicion of government agencies when you spend that money as a criminal. So we'll take a quick look at some regulations. Some of them are quite country specific, like the Bank Secrecy Act is a U.S. law. There are, each individual country has their own anti-money laundering laws, but there are also some global regulations. The United Nations has several conventions that talk about money laundering in the context of drugs and terrorist financing. And then there's also a financial action task force who have issued a set of recommendations for addressing money laundering that financial services firms and other firms will follow. And if you don't, the penalties can be very, very severe. These are just a sampling of some news articles. HSBC in 2012 was fined $1.9 billion by the US, which is a massive amount of money for allegedly having poor anti-money laundering processes in place and allowing Mexican drug gangs to launder money through their banks. You can see India's Canara Bank was fined in the UK and had to stop signing up new customers for a time. And then on the left, even a gambling firm was fined £2 million for not properly doing KYC and not properly identifying a money laundering case. So there are lots of penalties. It's a really serious issue, and even more recently in the news, you'll probably have heard about a number of ongoing investigations and fines. So it's a really big deal. So typical anti-money laundering processes, it's usually event-based. And the thing is that, traditional technology, traditional approaches, as Gartner says here, in the context of fraud, but also in the context of AML, traditional technologies and traditional approaches are no longer adequate to keep up with criminal trends, right? It's a constant arms race. Criminals are always learning new ways to avoid anti-money laundering processes, learning to avoid being spotted when they launder their money. So normally what you get is an alert for an event that happens outside of a normal pattern of behavior. These could be things like a very large money transfer, right? Something over $10,000 will trigger an alert, or maybe a transaction, from a sanctioned or a watch-listed country or a known tax haven. These sorts of things would typically raise alerts, right? Whereas the normal behavior passes through the filters. The problem with this is that they tend to be a lot of false positives, and poor data quality can really be an issue, right? You might get misspelled names. Sometimes your data isn't very clean, and that can cause problems with both your analysis and your alerts. And using this kind of event-based alert type of system misses out on patterns of behavior, right? And criminals tend to operate as rings. And so looking at just individual behaviors of one person or one event will miss a larger pattern of behavior that would be clearly suspicious, right? And using individual alerts, you miss the context of kind of all the data that you might have across all your different data silos, right? So all of these issues make it easier for criminals to avoid detection if they know how the types of filters that you are applying and the types of alerts that you would be raising. What we're going to talk about is using connected data to find fraudulent patterns, right? Patterns that would indicate a money laundering ring, right? Activity amongst multiple accounts, multiple pieces of data. So rather than just an individual event, finding a pattern of behavior in our data that is suspicious. This can help us lower the amount of false positives, which is a huge win. The fewer false positives you have, the less kind of sifting your AML teams have to do to get to the actual true money laundering cases. So it can save you a lot of money and a lot of time in dealing with false alerts. You're using all of the data that you have available, and we can get that view from across all of your different data silos, right? So maybe you have customer data in a CRM system, you might have payment data in another system, you could be bringing in external data about companies and how they're related. So all of this data can be combined together in the graph to give you a really rich view to find these sorts of patterns. And this makes it harder for criminals then to avoid detection. So Neo4j is designed as a database for working with connected data, right? And so this is what we're going to look at today, how using this connected data paradigm, this graph data paradigm, can really enrich your anti-money laundering activities. Neo4j is an enterprise-grade native graph database, so it's designed from the ground up to work with connected data in a highly scalable and very performant way. It's asset compliant, it's got security, it's designed for agility, so it's got all the features you would expect from an enterprise-grade database, which is what you would need if you are a financial services organization who needs to really work with anti-money laundering processes in real time. And what this allows you to do is move away from this idea of discrete data points, and move up the value chain where the connections in your data are really providing you much more insights into what's happening in real time within your data. Okay, so now we'll take a look at a sample database that we have here. So in this scenario, we are representing a fictitious bank. This bank is called Nubuck, the New Bank UK. What we're looking at here is the schema, the metagraph for the data that we'll be working with. So in light blue here in the middle, we have different types of account holders. A regular account holder would be a person, like a retail banking client. We also have some politically exposed persons. So these are people who typically require additional due diligence when you're onboarding them, when you're doing your KYC. And we also have some commercial clients. So these would be companies that work with our bank. These account holders have different type of data that can be associated with them. So they might have some passport information, emails, addresses, perhaps a loan, an unsecured loan. We would know their birth date. We also have some nodes here that we'll use for entity resolution. So as part of our demo, we'll talk about how you can determine how you can score two different account holders and to determine if you think that they're actually the same. So we have a name sound where we've taken the names of our account holders and run them through a SoundX algorithm, which gives them a number that you can then compare to see if phonetically names are similar. And then we have similarity nodes, which we'll talk about a little bit later, where we run a similarity algorithm in the graph. Of course, account holders have bank accounts. Bank accounts are from a financial institute. So our financial institution would be Nubuck, but also we would have information about some of the banks that we are sending money to or receiving money from. We would know what country that bank is in. And then we can also label some countries as either sanctioned or on a watch list. Then we have transactions. So bank accounts will send a transaction to another bank account. And then sometimes we also have transactions that are made with a phone rather than in person in the bank. Okay, so now that we've taken a look at the shape of the data, we'll do a little bit of exploration first. So we can do some kind of very typical types of searches. We might want to know, look at all of the transfers between one country and another country. So if we start with maybe transactions between the Cayman Islands, which can sometimes be used as a tax haven or someplace to open shell companies, and the United Kingdom. Okay, so here we have all of the transactions between these two countries. So here we have the Cayman Islands. And here we have Great Britain. In pale green, you can see here's us, our new bank. Here are a number of other banks that we've received transfers from. And then you can see transfers and individual accounts, right? So this might be something, if you wanted to look into all the accounts that we're sending money to and from the Cayman Islands, this is the sort of view that you might find useful. We can also take a look at transactions that are happening with sanctioned or watchlisted countries. So we can take a look at accounts that have interacted with Iraq, for example. Okay, so here's Iraq. We can see all of the accounts that have interacted, sent transactions to banks that are located in Iraq or have received money from banks that are in Iraq. And we can do the same with a sanctioned country. So if we pull up, for example, Iran, we can see here is here's Iran in red. as the country. We can see all of the banks with the transactions and the accounts at our bank that have interacted with the with account holders in Iran. So those are kind of pretty typical, maybe more MI or BI type queries that you might want to run. Now we'll simulate an actual investigation. So one of the things we might look for are circular movements of money, where you have an account that sends money to another account, that sends money to another account, and it moves around the accounts and it ends up back in the same account, right? So this could be called smurfing in anti-money laundering lingo, or layering, right? This is where you try to obfuscate the money, move it around a bit, so that it's less clear where the money has come from originally. So we have a query that will pull up circular money flows. And we can see that query returns two groupings of accounts. We can see here on the left, it looks like there's probably a couple circles that overlap, where money moves between a number of different accounts. And then here on the right, we have something that's a little bit more discrete. So we'll take a look at this one. And we can see in yellow are all the account holders, but we've got different icons for them. So here, Orville Loud, he's been tagged as a politically exposed person. So Orville is a city councilor. He's in government. We also have some commercial clients. So we have Manitowish real estate holdings, and then we have some just regular account holders, right? So if we take a look first at Orville, our PEP, we can see his bank account sent £9,428.21 at 4:56 to Manitowish. Then we can see at 6:12, that account sent £9,430 to Charisse. Moving along, we can see a transfer at 10:44 from Charisse to another corporate account of £9,411. That's for cleaning green dry cleaners. Then we can see they transferred at 12:01, £9,421 to Dolly. And then Dolly sent at 15:37, £9,428 back to Orville Loud. So we can see how the money has moved between these accounts throughout the day in a circular fashion, right? So this could raise suspicion, right? This sort of activity could be something that would raise an alert. So maybe we want to know where Orville Loud is getting money from. So if we take a look at the relationships, and specifically transactions where he was sent money, we can see there's here at the top, there are a couple very large transfers. So £8,999.99, £9,428.64. So, you know, beneath the normal reporting threshold of 10,000, that would clearly trigger an alert. Scrolling through many of these other ones don't seem very significant, just a couple £100 here and there. There's another big one there. We'll take a look at that one as well. And all the other ones, yeah, seem pretty trivial. So we'll reveal those extra money transfers. And we'll take a look at where they're coming from here. So this came from this bank account. The account holder, the person who transferred that money, was someone called Candice Durning. And that was from a bank called Reynolds Inc. And then this one, we can see that came from this bank account here. And that came from someone called Candy Derlin. And also from Reynolds Inc. So same bank, very similar looking names, Candy Derlin, Candice Durning, very similar. And we can see that this bank is located in Bermuda. All right, so if we take a look at Candice, we can see, we can take a look at the Soundex results that we found and see how they fare. So the Soundex result for Candy Derlin is K530D645, and this is 532 and 655. So similar, but not exact, right? So our phonetic algorithm wouldn't say that they're exactly the same person, right? But to do entity resolution only by matching names is there's one way to do it, but it's not necessarily going to give us the sort of detail that we really want. So what we've used here, we have a number of graph algorithms that Neo4j has written and published, and some of the newest ones are Similarity. So what we'll do is we'll take a look at the similarity of Candy Derlin and Candice Durning based on the accounts that they've transferred money to or received money from. So if they're interacting with a large number of the same accounts in our bank, then we'll have more confidence that they could be the same person because their behavior is very similar. Okay. So we can compare the similarity of Candy Derlin and Candice Durning. Okay, so now we've added a similarity node here, and it's quite a high score. So this uses the Jacquard similarity algorithm, and 0 is no match at all, and 1 is a perfect match. So here we have 0.846, which is quite a high number, right? So we can confidently say, because they've interacted with 11 of the same accounts, that they're highly similar, and therefore we think Candy Durnin and Candice Durning actually could be the same account holder, right? So that's very suspicious. It definitely looks a little dodgy, having two accounts with very similar names, behaving the same way from Bermuda, sending large amounts of money to our city councilor. So maybe what we also want to do is take a look at our corporate account holders that are involved here. So Manitowish Real Estate and Clean and Green Dry Cleaning Company. So what can we learn about them? What we can do is take a look at their ultimate beneficial owners. So there's lots of information that you can get about companies, who owns them. The Company House in the UK has this sort of information. There are websites and data providers that provide this sort of information. So financial services organizations might buy or bring in this sort of external data so that they can understand ownership of their clients. So we'll take a look at Manitowish Real Estate, the ultimate beneficial owner. So we can see Westminster Real Estate here. Real Estate Holdings owns Manitowish, and then there's a fund here called Silver Spoon Fund that owns Westminster Real Estate. We can do the same for Clean and Green. So find the ultimate beneficial owner. And what do you know? They actually have the same ultimate beneficial owner. We have Master Cleaners Limited own Clean and Green. They are owned by Green Industries Inc. And then ultimately Silver Spoon Fund owns both of these companies. Right? So again, this is a little suspicious. We've got money moving around between accounts that are ultimately owned by the same company, involved in this circular flow of money that could have originated with these payments coming in from Bermuda from these two very similar accounts. Right? And again, in a real life scenario, this sort of data would probably live in numerous different places in your organization, right? So using a traditional approach, a relational database approach, would make it really difficult to do this sort of investigation in real time like this. You might have information about your individual clients and their accounts in one system. Maybe you have payments information in another system. Your third-party data, about company ownership would be in another data lake maybe, or database. And so bringing all of this together in the graph to be able to work with it in this sort of a scenario, finding patterns and doing your investigation in real time is really very powerful. And this is the sort of tooling that can really remake anti-money laundering processes and really reshape your approach to working with anti-money laundering data and investigations. Okay, so hopefully that's given you a taste of how the graph can find suspicious patterns in your data and help with entity resolution. I'll hand it over now and see if we have any questions.
Hi, thank you very much, Joe. So just a quick reminder, if you do have questions, please feel free to just go ahead and write those in the questions box on your panel, and we'll read a few aloud now. So what was the format of the data that you consumed for your visualization example?
Sure. Mostly it was from CSVs. Certainly a lot of the information that we were looking at was randomized. So I use a random data generating website for names and account numbers and things like this. So mostly it was in CSV, and then I used our loading tools from CSV to populate the data.
Okay, great. And how would a client typically get the data into a system, given that it's often confidential data or unauthorized access?
Yeah. So this is the sort of thing that you would probably want, connected in real time. As transactions are coming through your organization, you would want to be able to add those to the graph pretty quickly. So that you're always working with fresh data and your investigators have, the most context that they can have available. So you could integrate Neo4j maybe with your enterprise service bus, or inject data into Neo4j from your application layer using one of our language drivers like Python or Java or JavaScript. .NET, something like that, or maybe an ETL tool to pull data out of a data warehouse or from your individual systems and put that into Neo4j. We do have a robust set of security controls. So it definitely, we would be working with confidential data here, right? This is personally identifiable information, people's names, people's account numbers, information about money transfers. So you would definitely want to make sure that only people who had access, only people who had the right privileges would be able to access that. So Neo4j does integrate with Active Directory, LDAP, and Kerberos for authentication and authorization. We have role-based access controls in Neo4j, so to limit who has the ability to write data as well as read it. And we do have those role-based access controls down to the property level, so you can control, at the level of individual fields, whether or not someone has the ability to access that.
Okay, great. And then obviously these would be quite large data sets. So are there any kind of limits to the amount of data that Neo4j can handle before affecting performance?
Yeah, there probably would be quite large data sets, especially if you're a very large organization, right? And um, banks often not only have their own accounts to look after, but sometimes they can act as a correspondent bank in money transfers, right? So sometimes two different banks can't send money directly to each other because they don't have that sort of direct relationship, and so they go through intermediaries or correspondent banks in between. So there's lots of data that a large financial services firm would have access to. For Neo4j, what we would consider a large graph would be measured in billions of nodes, right? Hundreds of billions of nodes. And we do have clients that work with those sizes of data, terabytes of data, billions and billions of nodes and relationships. And so, theoretically, the limit of the amount of nodes and relationships that Neo4j can hold wouldn't be something that you could reach. And so mainly your constraints would be hardware. So for these very large data sets, hundreds of billions of nodes and relationships, you would want a big server with plenty of cores and plenty of RAM. But these are the sorts of data sets that we would expect to see in production for enterprise clients.
And along the same lines, so for a client like a big bank who has millions of customers and all of their data already, how would you go about importing all of that into Neo4j when you're dealing with such large quantities?
Mm. Yeah, so your initial data load, might take a little bit of time, and certainly, you would have to understand the mapping between those data sources and Neo4j. But we do have, bulk loading tools and tools to help with the initial population of data to pull that data out from all your different data sources, map it into the graph, and then ingest it.
Okay. And is there a way to show payment amounts or frequencies in a graph?
Yeah. So uh, we do have here um, the amount, the currency, the date, and the time. You probably wouldn't want to have um, this sort of granular level of detail going back years and years and years and years, right? So you might keep this sort of very granular detail for recent data, and then you could aggregate that, combine it, and you could just say, more simply, this account sent this, this much money, over this many transactions to some other account, right? So you can definitely layer your data models for different purposes, right? One for aggregation and a high level view, and then while maintaining this sort of granular, very detailed view for specific use cases.
Okay. And is it possible to set up a workflow including some sort of alerts based on different rule sets or criteria? Or is this mainly just used for real-time investigation?
You definitely could build alerts. So what you would probably want to do, once you identify your pattern, maybe when you see these sorts of circular movements of data, all in very similar amounts, maybe within a 5% threshold of each other or something like this. Once you know that's the pattern you're going to be looking for, you can then write, it's like a trigger in a relational database, right? You can set Neo4j up so that when data is inserted and that pattern is found, that something takes place, right? So, and that something can be anything. It could be writing data to the database. You could make a call to another system, maybe to your case management system, set up an alert, something like that. So there are definitely ways of automating it so that you can be proactive as well as reactive, which is the scenario we just went through in a real-time investigation.
Okay, great. And during your example or your demonstration, you reviewed Soundex and similarities. Are
Mhm.
there any other features that you'd recommend to help deduplicate records?
Um, you could certainly do, more types of data comparison. So I think in this scenario, it's a bit tricky because obviously um, we don't have a huge amount of information about these two account holders because we have only the information that would have come through in the transfer, right? The Swift message or what have you. But if you have more information because they're your customer or something like this, you could do a richer comparison of data points. But I really like these similarity algorithms that we have now because you're looking at how similar the behavior of nodes are, right? How similar the graph surrounding them is. So you're structurally comparing them rather than just comparing data points, right? Like SoundX, which is useful, but has its drawbacks, right? I think these similarity algorithms can be really very powerful, and you could really enhance the query that you were using so that you could compare lots of different data points from around the graph for individual nodes.
Okay. Um, and how would you incorporate time in this sort of analysis or in the visualization, as most anti-money laundering patterns are time window based?
Yeah. So in this example, we only have a limited amount of data, and we're kind of only looking at one day. But Neo4j does natively support time fields. So dates, times, durations are property types in Neo4j. So you could definitely work that into your query so that you are only looking for transfers within a particular time window or circular movements of money that took place within a certain time window. You can definitely bring that temporal aspect into your queries as well.
Okay, and a bit of a broader question. So, uh, can you list any advantages, or are there any advantages of using Neo4j over a relational database like SQL Server in instances like this where you need to deal with a lot of unstructured data for data matching processes?
Mm. SQL is great. Relational databases are great. They've been with us for a long time, and they're good at what they do. In this sort of a scenario where you're working with very highly connected data, very large, very highly connected data sets, the graph is really a better suited to this sort of a thing, right? And in a relational database where you're trying to link all these different entities together, finding the circular movement of data that we ran it was between 4 and 14 hops, right? So doing that sort of path analysis in a relational database with joins and recursion is difficult and not very performant. So where you're doing this sort of thing, where you're working with highly connected data and the connections between the data are really very important to you, the graph is really the way to go compared to SQL, right? SQL is more suited, I think, towards maintaining a ledger, keeping track of all these individual transactions, in rows and tables. It's great for that. But when you want to look at the connections between transactions and bank accounts and account holders, the graph is really much more powerful.
Okay, and a lot of the example that you gave was within Neo4j Desktop. Does that come with only the Enterprise Edition, or is it also available with Community?
So Neo4j Desktop is a developer licensed download, and that is what I'm running here on my laptop. Neo4j Desktop does come with the browser. That's what this tool is here, and the browser is really focused on developers. So you can see here, you really need to know Cypher to be able to work with the browser, and this is our query for running the Jacquard similarity algorithm. So if you know Cypher and you want to work with your data in the desktop in the browser, that's great. The tool that we did most of the demo in, this tool here, this is Bloom. That's our visualization tool for end users. So it still runs using the same cipher. So you can see this is the same cipher query that we just showed you in the browser before, but I was able to hide it behind a search phrase so that an end user who wouldn't necessarily know cipher can still use the same functionality. And Bloom does run from desktop, but it is licensed separately and is for enterprise only, not for community.
Okay, great. And you also talked a little bit about an ETL tool when importing data into Neo4j. Is that a tool that Neo4j provides, or are there other tools that can be used?
We do have some ETL tooling that we ship. So we provide a lot of point-to-point integration functionality, to integrate Neo4j with a SQL database or a document database or a columnar store or what have you. We do also have in beta right now a more visual tool for integrating Neo4j with relational databases that helps you do the mapping and decide what data from your relational database will become nodes or properties or relationships or what have you. But there are a number of enterprise-grade ETL tools available on the market, things like Informatica or Talend or Pentaho. And those tools can also be used with Neo4j. So we actually do a lot of work internally with Kettle, which is the underlying ETL tool from for Pentaho's data integration.
Okay. I think we have time for a couple more. So thank you everyone for your questions, by the way. Is it possible to create or build out features from the links in your data that can be then fed into machine learning activity?
Absolutely, yeah. And that would be a great use for this, actually. So you can use the graph and integrate it with machine learning to look for new patterns, to identify new features in your data. So you can use it as a training data set. And then, of course, you could also take the output of that and feed it into the graph as well, right? So once your machine learning has identified some new patterns, or maybe it's scored, provided scoring or some sort of a ranking or created new relationships, those can also be fed back into the graph. So I think that would actually make a really, really powerful combination.
Okay, awesome. And as far as reporting this, so I know we talked a little bit about the fact that Bloom makes it easier for a non-developer, let's say, to gain insights. But is it possible to kind of build out a reporting dashboard if you wanted to export the graph, or are these kind of insights only possible through Bloom or Neo4j browser?
You could certainly, you can integrate Neo4j with standard BI tools, so things like Qlik and Tableau. Or you could build a custom dashboard as well. So a lot of Neo4j's clients do that. We support something called the Grand Stack, which stands for GraphQL, React, Apollo, and the Neo4j database. Also, there's a number of other JavaScript frameworks, D3 or Node.js, something like this. So you could definitely build a custom visualization layer, or integrate Neo4j into your existing application so that you can leverage the graph alongside your other interfaces.
Okay, great. And would you be able to kind of set up alerts through something like that?
Yeah, and kind of in the same way, I think either, as I said, you could create a trigger, or maybe you could make an alert node in your graph when a particular data insert or update matches a pattern, and then you could use that interface to parse all your alerts.
Okay, and we'll squeeze in one more here. So, is it possible, or is there an option to kind of schedule jobs within Cypher? So, kind of a recurring query or something like that.
Yeah, you could definitely schedule jobs, the equivalent of a cron job or something like this. to run a nightly batch, to look for queries or to run, regular analytics or what have you. You could definitely schedule these sorts of things as well as doing them ad hoc.